This lecture, we're going to get into spectroscopy, looking at the first topic in the course. So if I had to mention the sort of major types of spectroscopy, I would start with a question. When we do chemistry, so just kind of reminding us all that we're chemists again, the good old life. When we do chemistry, how do we know or come to know or find out the structure of a molecule? And by structure, I'm referring to the bond line structure. And it could be for anything that we're working with. So for any of the chemicals that we're working with or studying, how do we come to know the structure? I mean, of course, when we're in class, I provide them for you. But the answer is analytical techniques. And while analytical techniques often falls in the realm of analytical chemistry, and you might think of courses like our quant course, typically called the sophomore analytical chemistry course, there's some other major types of analytical techniques that are used by organic chemists to determine the structure of a molecule that aren't necessarily taught in the typical kind of sophomore level courses, sophomore analytical chemistry courses. And those are, if we get into the major techniques used by organic chemists, they are mass spectrometry. And I really wish I could devote a considerable amount of time to mass spectrometry in the course, but it's just too challenging to try to fit everything in, just to be honest with you. So we will just mention it in passing here. So mass spectrometry is an analytical technique that determines the molecular weight of a molecule. So this will tell you if you inject some white powder, some colorless oil into a mass spectrometry instrument, it will tell you what the molecular weight is of that stuff. So it's not a balance. It's not, you inject a gram, it's not going to get back a gram. Rather, if you inject a gram of water and something's tuned so that it can detect water, it will tell you, oh, whatever you injected has a mass of 18 grams per mole. Okay, so it'll give you the molecular weight of a molecule, which is great. But what we're focused on is spectroscopy. So spectroscopy is an analytical, or really a class of analytical techniques that study how light interacts with matter. Okay, so class of analytical techniques that study how light interacts with matter. Okay, so let's get into the types of spectroscopy. Sorry, I had to turn the page there. The types that we're going to look at are a little bit of IR spectroscopy. So IR meaning infrared spectroscopy. And this technique uses IR radiation to gain insight into covalent bond strengths. We looked at this in organic chemistry 1, not fairly extensively. I mean, we didn't do too much in terms of lecture, but we did a lot in the lab related to IR spectroscopy. So this gives insight into covalent bond strengths and allows us to determine which functional groups are present. Okay. So as I mentioned, we talked about that quite a bit. Now, what we're going to focus on, particularly extensively in the first learning module of the course, is NMR. So NMR is really the major topic. We would call this the NMR unit. This is nuclear magnetic resonance spectroscopy. Okay. And so that's the abbreviation. Now, what this does is this tells us or provides insight into the chemical environment around a certain nuclei. So by nuclei, I'm referring to a single atom of a particular element. And I could just stop there, but I'm just going to say element type. Now, what this is saying is that this is going to look at a single, for example, 1H atom, C13 atom, and these will be the focus, primarily the 1H atom of this module. Or we could do 31P or 19F, or I believe it's 15N. I'd have to check on that. These are the atoms that we're going to be looking at when we do NMR spectroscopy. I'm just going to make sure. I've never done 15N NMR. Yep, it is 15N. Okay, so what I'm saying is we're going to pick on a particular nuclei within a molecule, and then we're going to focus on a particular element type within that molecule. So we'll start by saying, let's look at only the 1H atoms, and then we look at each 1H atom individually to determine or really gain insight into its chemical environment. So the chemical environment is just like those two words, I guess, resonate with you a little bit. What this means is what type of environment, what type of surroundings does this element that we're studying have? Okay, so the chemical environment around a certain nuclei. Now, if you notice, as I'm listing the elements down at the bottom of the page, I've got their atomic mass listed as a prefix in front of the element. Now, that's important because there are sometimes different types of NMR techniques for different isotopes of an element. For example, deuterium, or 2H, hydrogen with just an extra neutron, so its atomic mass is actually 2 instead of 1. That requires a different NMR technique than 1H NMR. And 1H NMR we'll do all the time, C13 also all the time, but we will rarely do like deuterium, which is 2H, and then never do carbon-12 NMR, as we'll see as we progress through the course. So having those isotopic labels is important. I'm going to turn the page. So, oops, got my highlighter on here. We note that we need to include isotopic labels when talking about NMR a particular NMR technique. Okay, so for example, we put the 1H or the 13C, and that isotopic label can be seen by the atomic mass of the particular element. Okay, so those are the techniques that we're going to look at. Now, what we could do just briefly, or maybe we should save it for the next lecture. This is kind of a nice warm-up lecture for us. And what we'll do in the next few lectures is look at IR spectroscopy, or excuse me, spectroscopy with a little bit more physical details. Okay, so that'll be it for this first video. Short, sweet, hopefully marginally insightful.